So I just found this little trick here that no one else has posted for significantly boosting your VM CPU performance. It can get you the same performance on this little system as like a cheap AMD 8-core FX system. It's old, slow. Same performance on this as you get on like those 14-core Xeons that cost many times more. So let's first get like a basic CPU performance overview. I already ran this before. I got about 400 points, might be a bit higher right now. And this is Windows 10, but it also will work perfectly in, right here is Fedora 25. I'm going to try to just show that off as well. So, let's get a little bit of a baseline performance here first before we show you any of the changes. So also, once this one finishes, I'm going to go and do the same thing in Blender. Now, I might be showing you some 3D rendering programs, but this will work in any other program. So let's get into the actual trick here. Now, a lot of programs don't let you do this because they're closed down and they want to make sure that people actually go and buy the high-end CPUs and not just get the most out of the really cheap ones like I'm going to show you to do it. But open source software normally seems to do it. You got to get the right thing. This is Commute VirtualBox. So this is managed via Virtual Machine Manager on Linux. I'm using Fedora, but distro doesn't really matter. Now it lets you do some things you normally can't do. What you want to do is, so first thing is you got to pick the correct CPU. So you want to run the newest one. So this one's Opteron G5, so I'm getting the full server CPU performance, not the AMD FX. You got to select the Opteron or the Xeon option. Next thing, you want to manually set the topology. It will normally select on automatically to try to match the CPU performance. Now, but you can get more here. So it says 8 sockets here. I'm going to shove 16 cores here as well. And I'm going to change our current allocation to 128. May give you a little bit of warnings here, but ignore that. They're just trying to keep you from using this little trick. Now, if I start it up, it's going to boot normally, and you won't notice anything until we get into the testing. And we can do the exact same thing over here with my Windows system. That was my Linux one. So if I go into my Windows system, I can do it. Now, I will warn you one thing about Windows. Due to the way Windows is set up, you are limited to 2 sockets on any Windows desktop system. So that means you may have to increase the core count a bit more. So you want the 128 total, because that's the limit in this program. Now I am working on something. I'll show you that in just a second. So I should be able to use 64 cores each socket. You do want to keep the socket count a bit higher, but this should work fine when I fire it up. This is going to get a little bit more technical and into the programming level stuff, but this is using a little program called Commute to do the virtualization here. Now what we can do in order to play with it is there's this little file. This is what makes the program. This is all the source code. You can go download it from commute.org. Now you can go into a little program called cpus.c. So it's the C file that controls all this. Now this is what manages all the CPUs behind the hood. And these are all those limitations are that keeps you from using too much CPU on the lower end chips. Now I haven't hunted through all of this, but there is a few lines you have to find. I'm going to post a new video soon of showing which lines you have to change in here to get you a bit more performance out of this system. And basically those are the lines that limits you on your max cores and how much stuff every core can do in like a given second. So there's a few lines in here that's going to say what your max cores are, and it looks at your current CPU and it limits you to that many cores. So now we've done a little trick on the Fedora system. We can see all 64 cores. You can see how many there are right now. So now if we go and switch back to on here, switch back to Blender, we can render it, and we're going to notice it's going to render a lot faster than it did last time. I think it's rendering about a quarter of the time now, thanks to the little trick. There's Windows 10 right here. As you can notice, its disk is running really hard because I'm running on some slower hard drives, but if you run it on SSD, it'll be really fast. These are all these CPUs. Look at all of them. So now if I go and fire up Cinebench, we're going to notice a much higher rendering score than we recently got, just because we have so many more processors now. Look at that Cinebench score right there. That is amazing performance you can get. So thanks for watching this little video of improving performance with virtual machines, and subscribe for more performance and other videos like this in the future.